3.4 is our last conic section, hyperbolas, and it's the weirdest one, okay? Because there are two things, and if you look at that graph over to the right, it almost looks like two separate back-to-back parabolas. We can't really call it a parabola because it's not the same pattern, but look at, oh, hopefully this will come up. Here we've got our conic section, and if you notice, if you spin this around, if we take our knife and we cut through at a certain angle, it's going to cut through both of those cones. It's going to cut through both of those cones, and it's going to make that exact shape that looks kind of like a parabola there inside of each cone, I guess, right? And so that's what this is doing. Now, I know it's super complicated and there seems to be a lot going on, but if I cut it just so, it's going to end up cutting into both of those things, and that's why we're going to end up having both of those lines. All right, so let's take a look at this big old mess. And when you look at this, you have to notice that this distance right here is C. And they're trying to show you in the picture, but I think it's really hard to get out of that picture. But we still have focus points, just like we did with the ellipse. And C is going to be the distance between the center and the foci, or the focus points. So you've got this distance right here. Here's a focus, and here's the center of this. And C is that distance. So we've got an equation here, and this looks an awful lot like Pythagorean's theorem. But that's how you're going to calculate the coordinates of the foci. Now you do have A and B, and you have to know what A and B are as well. So A is the distance from the center to the vertex, and B is the distance from the center to the co-vertex. And it's a little bit tricky here, but you'll see how it goes once you're looking at an equation. Notice when they give you the general form of the equation, you want to pay attention to which direction it's oriented. And so when it's oriented in the x direction, like this one is, then the x part of the equation is going to be positive. All right, this part. I mean that positive because there's always going to be a subtraction. The only difference between this equation and the last one, the ellipse, is this one has a minus in it. Last one had a plus in it. Okay. When the graph is oriented in the y direction, you've got the y part is your positive part, and the x part is being subtracted. All right. So you're going to look at an example like this example 0, and you should immediately see that this one's going to be oriented in the x direction because the x part is positive and the y part is negative. All right, so I can tell, as soon as I see that minus, I know it's a hyperbola, not an ellipse, because the equation looks an awful lot like an ellipse. If I made that into a plus, now it's an ellipse. But it's not a plus, it's a minus. That's how I know it's a hyperbola. It's going in the x direction. So we can do kind of the same things as what we did for an ellipse. If we want to find the center, do it the way that you always find the center. The center is going to be at the point +1, -2. And sometimes it's hard to know which one's A and which one's B, but last time A was the bigger one and B was the smaller one. This time it doesn't really matter which one's bigger and which one's smaller. It matters which one's positive and which one's negative. So in this case, A is 5 and B is 3. So I think it helps a lot of the times to sketch out a drawing. Even though they didn't necessarily tell me to, I'm going to. The center is at the point 1, -2, right there. And I know it's X part is going to be 5 away from that. So 5 in the X direction. So if I go 1, 2, 3, 4, 5, that's where one of the vertices is. And 1, 2, 3, 4, 5, that's where another one of the vertices is. Okay. And if I go 3 up, so 1, 2, 3, that's where the co-vertex is, and 1, 2, 3 down, like this. That's where the other co-vertex is. And not real symmetrical, but pretty good. Typically what you're going to do is draw like a box through those dots. And then what you're going to do is you're going to draw the diagonals. The diagonals are going to be asymptotes for this. I don't know if you noticed those diagonal dotted lines in these pictures. Those are asymptotes, and those are going to serve as the boundaries for this graph. It's going to help me to draw them. So if you can get all that drawn in, I drew them dotted because they're not really there. They're just kind of boundaries and guidelines. But I know this graph is going to be, it's going to look something like this. Something like this. I don't want to cross those lines. Those lines are the boundaries. Those are the asymptotes. But anyway, what am I supposed to do? Find the vertices. Okay, the vertices are these 2 points. Remember, I went over 5 in the x direction. So 5 in the x direction, I changed the x number and I added 5 and I got 6, -2, and I subtracted 5 and I would have gotten -4, -2. Those would be the vertices. And then your co-vertices were these 2 points. And in this case, I changed the y number. So I added 3, and that would be the point 1, 1. And I subtracted 3, and I would have the point 1, -5. And the only thing I don't have on here is the foci. And the foci, you're going to need this equation up at the top here. C squared equals a squared plus b squared. We've got a squared is 25 and b squared is 9. 25 plus 9 is 34. C squared equals 34. So we're going to need to square root that. Now, technically, that equation has 2 roots, but since we're talking about distance, we'd only use 1. Square root of 34 is very difficult to visualize, so I'll see what it looks like on a calculator. 5.8 or so, about 5.8. And so what happens is I end up having to go a distance from that vertex, or from the center, I mean, from that center, 1, 2, 3, 4, 5.8 puts me about right there. And what are the coordinates of that? Well, I took my x number and I added 5.8, so that's going to end up being like what, 6.8, comma, -2 or so. That's one of the foci. And then I would have to go 1, 2, 3, 4, 5.8 in the other direction. If I subtracted 5.8, what would that be? -4.8. -4.8, comma, -2. That's your other focus point. Remember, the focus point is going to be inside of the curve, just like it was on the ellipse, just like it was on the parabola. The focus is going to be inside the curve, but you've got 2 of them. All right, there's a lot going on there. But that's basically the whole lesson. If you can do that one problem right there, you can do pretty much everything. Sure. All right, example 1 says graph this thing, give the domain and the range. Well, I'm basically going to do the exact same thing as what I did a second ago. All right, let's find the center. What's the center point? 0, 0, right? 0, 0, and that's the same. It's the same as all of them. Girls, you good? You have a question? No question? How did I get negative 4 point? Is that wrong? If I, okay, where did this negative 4.8 come from? If I'm right here, I'm at 1. So I'm going 1, 2, 3, 4, 5. And right now I'm at negative 4. And I go over, if I go over 5.8, I've gone over to negative 4 because I started at 1. And so basically 1 minus 5.8 is negative 4.8. Now that was rounded off, remember. That's not exact. I just used that number because I know where 5.8, I know how to count to 5.8. I don't know what to do with square root of 34. Technically, we should have said something like 1 minus square root of 34, comma negative 2. And 1 plus square root of 34, comma negative 2. But I think that's a lot harder to visualize. All right, good question. Need to ask stuff like that. So the center point is at 0, 0. All right, fine. What's A? 2. It's tricky because last time A was the bigger number. This time A is the positive, the first one. B is 5. And that kind of tells you if this thing is tall or short or whatever. But that gives me a lot of information for this graph. I know that this thing is going to be taller than it is wide. So that tells me to make my graph taller. All right. And the center is at 0, 0. And I'm going to go over 2 in the x direction. And I'm going to go 1, 2, 3, 4, 5 in the y direction. 1, 2, 3, 4, 5. Try really hard to make your units, your tick marks evenly spaced. The better you draw the graph, the easier this is to do. So this is what it's going to look like. And I'm going to draw a box here. And the box doesn't really do anything for me other than it shows me the corner points, and it's going to be easier to draw my asymptotes through those corner points. If I didn't have those corner points, it would be a lot harder to do. So asymptotes are going to go from corner through the center to the other corner. Okay. So the nice part is it doesn't ask me for the focus. I don't need the focus here. I just need to draw the graph. And I know this thing goes in the x direction, right? It goes in the x direction. So make sure your graph goes in the x direction. Domain. You should be getting good at domain by now. If I squash this onto the x-axis, it's going to cover from negative infinity to negative 2, unioned with positive 2 to positive infinity. If I look at the range, squash it onto the y, look at the y numbers covered, it covers everything. Negative infinity to positive infinity. Graph the function, give the domain. It doesn't ask me for the foci. If I had to find the foci, I would go c squared equals 4 plus 25. That's 29. I need to do the square root of 29 and go that distance away. All right, so what is the square root of 29? It's about 5.4. Square root of 29 is about, did I do that right? About 5.4. So, interesting. 1, 2, 3, 4, 5, 6 there, and 1, 2, 3, 4, 5, 6 right there. Those would be your focus points. And so how you'd find the coordinates of that, if you started at 0 and went over in the x direction this much, square root of 29, comma 0, that's one of your focus points. And you started at 0 and subtracted or went over this way, negative square root of 29, comma 0. Those would be your 2 focus points. Your asymptotes, sometimes you need the equation, and that helps to do the slope. And find the slope of this, you go up 5 and over 2, up 5 and over 2. So that asymptote is y equals 5 halves x. For the other one, you go down 5 and over 2. So that other one is y equals negative 5 halves x. We can find the equations of the asymptotes if we need them. Number 2 is the same question. This time it's not quite written in standard form. Just like the ellipse, we want it equal to 1. We want the thing equal to 1. And so this is the same as the last lesson. It's very, very similar. I'm going to divide by 400 because I want 1. And I want to reduce some fractions, and that might require, how many times does 16 go into 400? Well, that's 25. So this is going to be y squared over 25 minus x squared over 16 equals 1. That's my standard form. You got to get it to 1. You got to get it to 1. All right, so when I see this, this one is going to be oriented in the y direction, and you can tell because the y variable is positive this time and the x variable is being subtracted. You can see that a is 5 and b is 4, and those numbers are going to help you graph this. You got to go 5 in the y direction and 4 in the x direction. 5 in the y direction, 4 in the x direction, but you probably need to find the center first. What's the center? Center is 0, 0 again, right? So if we're going to draw this thing, center is at 0, 0. I'm going to go 1, 2, 3, 4, 5 in the y direction. 1, 2, 3, 4, 5. And 4 in the x direction. 1, 2, 3, 4. 1, 2, 3, 4. This is very similar to what we did in the ellipse, right? When we did in the ellipse, we just drew a curve through those 4 points. Now we've got to draw, however you want to describe this hyperbola shape. I think this box really helps. Asymptotes go from corner to corner through the center point. Oh, that's terrible. Okay. And don't forget, which direction is this oriented? Y direction, X direction. This is the Y direction. So we need to make sure we draw this in the Y direction. Vertex here. Vertex here. Okay. So domain, all real numbers. Range, this time it's not all real numbers. Start down here at negative infinity, whoops, negative infinity, and goes to, what's this number, negative 5? From negative infinity to negative 5, unioned with positive 5 to positive infinity. Now, it doesn't ask me for the focus points, but I think that's the hardest part. And so I'm going to go ahead and put that on there. We're going to find the focus points. So c squared equals a squared plus b squared. That's going to be 25 plus 16 is 41. C is going to equal the square root of 41. I can't picture 41. I don't know square root of 41. We are much, much better with decimals. Square root of 41 is about 6.4. So we go 6.4. 1, 2, 3, 4, 5, 6, 7. There's 6.4 right there. And 1, 2, 3, 4, 5, 6, 7. 6.4 is about right there. So you look at those focus points, and you're changing the y value of the vertex. So your foci are going to change the y value of the vertex. The x value is still 0, but the y value, if you go up, is square root of 41. Yes, I realize we know what 6.4 means a lot better, but to write the exact number, you went up exactly square root of 41, or you went down exactly square root of 41. Those are the coordinates of the two focus points, the foci. Your asymptotes, all you have to do is think about, I went up 5 and over 4. So your asymptotes, y equals 5/4 x, and y equals negative 5/4 x. Sometimes they'll ask you for the equations of the asymptotes. I don't really care about them, but sometimes they'll ask. Number 3, same question. Can you tell which direction this is pointing or oriented, x or y? It's going to be oriented in the x direction, and you can tell because the x variable is the positive one. All right. Now, one thing that's weird about this one is the second one's not written as a fraction, but you can always put it over 1. It's fine. Okay, that's fine, right? So your A number is 4, and your B number, square root of 1 is 1. So your A number is 4, your B number is 1. We're going 4 in the x direction. We're going 1 in the y direction. What's the center point, though? Center point is 2, negative 4. Very good. This one's going to be harder when it's not centered at the origin, because you got to go 5 away from that point, and people kind of mess this up. So it's 2, negative 4. That's the center of this thing. One, two, 1, 2, 3, 4. We good? Question? 2, negative 4. There's the center, right? So the A number is 4. That means I'm going to go 4 in the x direction. So 1, 2, 3, 4. Try to line this up. And 1, 2, 3, 4. There. 4 in the x direction. And only 1 in the y direction. So 1 up is right there, and 1 down is right there. Draw that box through. Whoa. Diagonal lines through the corners, through the center. Oh, I missed totally. Ugh. That was terrible. Okay. And then it's oriented in the X direction, so let's go ahead and knock it out. I don't think drawing it is the hardest part. I think finding the focus points is the hardest part. Whoa. Try to make it a curve. There's the graph. Should be able to give the domain and the range. Domain goes from negative infinity to, what's that number right there? -2. Your X number is -2. Unioned with this X number over here, 1, 2, 3, 4, 5, 6. That's 6 to infinity. And then your range, talk about the Y numbers, is going to be everything. Okay. Now again, I know they didn't ask for the focus points. I think that's maybe the hardest part. So let's go ahead and talk about that then. C squared equals A squared plus B squared. That's going to be 16 plus 1 is 17. So C is the square root of 17. That's a distance, right? That's a distance. I don't know what square root of 17 is. Square root of 17 is about 4.1. About 4.1. So what we would need to do is go 4.1 from the center. Not from 0, not from the origin, but from the center. So that's what people kind of mess up here. All right, if we're right there, we are at -2. No, not -2, +2. And we're going over 1, 2, 3, 4.1 puts me right there. 4.1. And so if you were allowed to say a decimal, it'd be 2 plus 4.1 is 6.1 comma, where are we at? -4, right? Okay. But here's the thing, and here's the thing that people really, it blows their minds. If you had to use the square root of 17, if you had to give me the exact number, we can't use the 4.1. We started at 2 and we added the square root of 17. That is your X coordinate. That equals 6.1, or that's approximately 6.1. So 2 plus square root of 17 comma -4 is actually the exact location. So now I do the other one. I'm going to go back 4.1. So if I start here at the center, that's at 2, and I go to the left, 1, 2, 3, 4.1 puts me right there. And so this is -2. And so this must be at what, -2.1? -2.1 comma -4 is approximately that point, because I started at 2 and I subtracted 4.1. That got me -2.1. But exactly, you got to think, well, I started at 2 and I subtracted whatever the square root of 17 was. And people really have a hard time with that. Foci. If you had to do Math Excel, they're going to make you say 2 plus square root of 17 comma -4 and 2 minus square root of 17 comma -4. I know that's tough. Okay. We talked about eccentricity of an ellipse, and it was roundness, right? Kind of a similar concept here. Eccentricity equals C over A. Narrow hyperbolas have an E value near 1, like this one. The larger E is, the wider the hyperbola, like this one over here. E equals 5 is a wider hyperbola. So number 4, find the eccentricity of this hyperbola? Well, E equals C over A. We can see that A is 10 and B is 9 pretty quickly. We need to find C using that same equation. C squared equals A squared plus B squared. That's 100 plus 81. That's 181. C squared equals 181. So C equals the square root of 181. So then the eccentricity is going to be the C value over the A value. Square root of 181 over 10, square root of 181 divided by 10 is about 1.3. About 1.3. Number 5, this last one. Find the equation of the hyperbola with eccentricity 3 and foci at negative 2, 5 and negative 2, 3. All right, so we have to find the equation. We're going kind of backwards here. I think it's kind of tough to do this without drawing a picture. And a lot of students will not draw a picture because it doesn't tell you to draw a picture, but you're trying to figure out some stuff. And you look at this and you don't really know what to go or where to go. So what I would almost always do is just start sketching something out, just see if some pieces can fall into place. So I've got negative 2, 5 and negative 2, negative 3 are my foci. Negative 2, 1, 2, 3, 4, 5. And 1, 2, negative 3. Okay. Those are my foci. Now, I bet you the center is right in the middle, right? Wouldn't the center be right in the middle of those 2 points? So that's going to be something that's kind of important. We know the center is, let's see, this is 1, 2, 3, 4, 5, 6, 7, 8. That's an 8. The major axis there would be 8 units long, so it must be 4. Go 4 in the middle. 1, 2, 3, 4. This must be the center point right here. The center point is negative 2, comma 1. That tells me an awful lot of information now. All right. I know the focus, since the focus are oriented in the y direction, I can tell this is going to be a hyperbola that's oriented in the y direction. So as for my equation, I don't know the answer yet, but I do know it's going to be y first. Y minus 1 squared over something minus x plus 2 squared over something equals 1. All right, so I need to know my A and my B number, and I can finish this thing up. All right, well, the distance here is 4. Remember, that's C. C is the distance from the center to the focus, right? C is 4. So what else did they give me? They didn't give me A, they didn't give me B, but they did give me that eccentricity. So that's kind of a weird thing to give me, but remember, we've got a formula for eccentricity. Eccentricity is C over A. So I know the eccentricity is 3, and I know the C value is 4. So I should be able to solve that equation and find A. I don't like my variable on the bottom. Multiply both sides by A to cancel out here. 3A equals 4 divided by 3. A equals 4/3. A equals 4/3. That's a weird thing. A equals 4/3. So that means A squared equals 16/9. A squared is 16/9. So that's kind of gross to put right there. A squared equals 16/9. And then what? We have to find B. And so we can use this same equation. C squared equals A squared plus B squared. We know the C value was 4, so squared is 16. We know the A squared value is 16/9. And we need to know B squared. So we can subtract this over. 16 minus 16/9 is your B squared value. So 16 minus 16/9. If you need to subtract fractions, get a common denominator. Multiply by 9/9. 9 times 16. It's 144. 144/9 minus 16/9. 144 minus 16 is 128. You get 128/9 equals B squared. I wish those numbers were easier, but whatever. B squared, 128/9. So the only thing left to do, it's a little bit weird that you are dividing by fractions. Remember how to divide by fractions? If you divide by fraction, you're multiplying by the reciprocal. So if we think about multiplying by the reciprocal, and multiplying by the reciprocal, that changes us to 9 y minus 1 squared over 16 minus 9 x plus 2 squared over 128 equals 1. That's tough stuff. Other than that, it's just kind of review stuff. Eccentricity of a parabola is 1. Eccentricity of a circle is 0. And ellipse is this equation, but it's going to be between 0 and 1. Hyperbola is this same equation, but it's going to be greater than 1. And then this is just kind of review. Puts everything together, all of your equations, your shapes, your relationships, what the graph looks like, lots of different stuff there.